amplifier. So we're going to walk relatively quickly, highlighting the main important points. We said last time that the differential amplifier, when it is of this form, if I'm applying a differential signal to both sides, then the node S is roughly a virtual ground. And as such, I can model the circuit into two half circuits. And if I have the point S here, okay, it is a virtual ground, and I have VID over 2 here and minus VID over 2 here. This can act as a half circuit, as a common source with input VID over 2, and accordingly, after we derived the whole thing, we talked about the half circuit concept. هلا كمان we introduced last time two concepts. The first one is that if I am looking at the differential gain AD with respect to VID, then I can obtain it in two modes. One is looking at the differential output, which is the gain of VD2 minus VD1, okay, over VID. And the other one is the single-ended, which is VD2 or VO2 basically, or VO1 over VID, or VID1 over VID. هيدا بيكون single-ended, and this would be the differential output. Okay, and then we said, well, this kind of circuit is not affected by the resistance of the current source, or because the V node S remains 0. And then we said, well, RO, well, then we will simply replace RD by RT parallel to RO if we have RO. Okay, and we derived finally for this circuit that the gain is GMRO parallel RT, or in the single-ended fashion, it's half GMRO parallel RT. And we said if we really just take the transistor level circuit and we set node S to 0 in small signal analysis, the problem is equivalent to a common source amplifier, which is biased at half the current, and I'm inputting to one side VID over 2, and I'm inputting to the other side minus VID over 2, and this would be VO2, and this is RT. Okay, and now I can easily derive VO1 على VID over 2 إن هي minus GMRO parallel RD. Okay, and therefore VO1 over VID is really minus half GM times RO, little RO, pardon me, little RO parallel RD. Okay, so in this scenario, we can rederive the analysis and rederive both sides. And here the input is minus VID over 2. And we can find VO2 على VID بيطلع positive sign plus half GMRO parallel RT. In a similar way, we introduced the half circuit for the differential input. Okay, we will introduce the half circuit for the common mode input. Yani if I have the differential amplifier with input VICM applied to both sides and it has two outputs, what happens in the small signal analysis, we're going to do the derivation assuming that the current mirror has an effective resistance RSS, and of course after the derivation we can let RSS tend to infinity and see what the analysis will give us. But first let us examine this. In small signal analysis, when I apply the same input to both sides, then I would expect that this would incur a differential signal, okay, and this differential signal, which is equal current in both sides, which is equal, is going to flow into the resistor RSS, right? Because the sum of the DC currents goes to I, and then we're assuming that the excess differential signal, which will be built plus I on both sides, should flow somewhere. So I need to have it flow into RSS. Okay, so let's see. And then later, when RSS tends to infinity, we'll find that the gain becomes 0, meaning that I cannot create this current. Okay, and it has to go somewhere. Okay, if I create it. So this means that the current that is flowing here, if this is plus I have plus 2I here. Okay, so now this is open, this is a ground, إذا عم بعمل small signal analysis. Now, if I want to build the equivalent circuit, what do I do? If I want to build the equivalent circuit, this means that on the right side, I have, this is grounded, this is RD, okay? Of course, this is also small signal analysis. طيب ما هيدي عم تبعت I, okay? This is sending I, and by virtue of the fact that this is one transistor, and I'm getting a current I here in small signal, this means that I will also get the same current I in the RSS. So I have some resistance here. I don't know what its value is. Okay, but I know that I have the same current should flow in the small signal analysis, and this is the VO1. Okay, the condition for this half circuit and the transistor Q1 in the full circuit to be equivalent, I have to maintain the same voltage Vs. In small signal analysis, what is Vs? 2I times RSS. Type, to have the two circuits equivalent, what should be this resistor? يعني شو الفولتج هون هو I times R. So I want I times R to be equal to 2I RSS. يعني R بده يكون شو بيساوي؟ 2 RSS. Okay. فإذا the equivalence can be achieved. The equivalence can be achieved if I set a resistor here equal to 2 RSS. Okay, صفى, this transistor will have the same current flowing in the half circuit. It will have the same built voltage here. It will have the same built voltage here in small signal analysis, like the big circuit. Okay, فإذا what they teach us is that if I want to split the half circuit for the common mode, because of this, any impedance I see at this node, I'm going to multiply it by 2 and I will break the circuit. We can think of it also 2 RSS parallel to 2 RSS. What does it give me? RSS. And we can think of it as if I had two resistors in parallel and I broke them and I gave one to the left side and one to the right side. Or we can think of it of maintaining the same voltage here at this node S. Okay, great. So impedance, we multiply it by 2. Okay. And we get the half circuit. هلا this half circuit, it's simple for us. It is what type do I have here? This is a common source with what?
With source resistance.
Exactly. So we know the formula, and the gain is typically VO over Vn is minus GMRD over 1 plus GMRS. In this case, we will really replace RS by 2 RSS. Okay, so this will be 2 RSS. Okay, and Vn is nothing but VICM. So I can know what VO1 over VICM is, and I can know what VO2 over VICM is. Okay, great. So now I can derive the gain. I need to derive the common mode. So this is VO1 and VO2, they both have the same formula and it is the same circuit, and we placed RS by 2 RSS. So I need to find the common mode gain. For the common mode gain, I have the single-ended output, يعني VO1 over VICM and VO2 over VICM, this is the equation. And then for the common mode, if I want to find the differential output, okay, I'm not looking at the differential gain. I want to find VO2 minus VO1 over VICM. Okay, so in this scenario, this ACM, it will be equal to what? 0. They are the same. So this ACM will be equal to 0. طيب great. هلا if we want to look at the full circuit, نحن اتفقنا انه I will have AD and I will have ACM and therefore I will have the CMRR, and here I can have the single-ended output and I can have the differential output. Okay, in this scenario we said the single-ended output is plus or minus half GMRD. A single-ended output here will be minus GMRD over 1 plus 2 GMRSS. Here it is 0 and here it is minus GMRD, طبعا parallel RO if there is RO in this case. طيب. So in here CMRR هو 20 log, right? This is 20 log AD over ACM in absolute value. So denominator is 0. This is infinite. This is ideal. This is what I'm going after. In this case, in the single-ended, I will need to reduce the expression as we will see next. Okay, but the most important thing is that you are able to identify that this is the gain with respect to VID and this is the gain with respect to VICM. هون هو VO1 or VO2 over VN يعني هو VID أو VICM, and here it is the difference, and they reserve the right to take the difference in any direction where Vn is Vid or Vn equal Vicm. Okay, so best be comfortable with those expressions that you can have differential gain مع single ended, differential gain مع differential output, common mode gain مع single ended, or common mode gain مع differential output. Okay, anybody has any questions? Okay, طيب great. Yeah. Okay, so لكن هلا I'm gonna clear this and look at the derivations here. So in the derivation he tells me that for differential output the common mode will be 0 لأنه the expression are the same and the CMRR will be infinite. For the single-ended output the common mode will be one of them, so it is this expression here, and the CMRR is 20 log AD على ACM. So this is AD, حطلي الهاف GMRD لأنه I'm gonna take absolute value anyway. And over ACM, this is GMRD over 1 plus GMRSS in the numerator. So these two will cancel and we multiply the half into this. So بتصير هيدي half وهي بتروح بصير عندي half plus GMRSS. Okay, now if we examine this, if RSS is very large, the CMRR will be very large, which will be the ideal value is infinity. And if CMRR tends to infinity, if RSS, tends to infinity, the CMRR will also tend to infinity. Okay? يعني if you have a current source whose resistance is infinite, automatically you can plug this in and say for the single-ended output, RSS tend to infinity. Therefore, the A common mode tend to 0 and the CMRR will tend to infinity. Okay? طيب. Questions? Okay. Yeah. طيب, let's look at this circuit. Let us examine it. What's the difference here? Instead of having the resistor RD, with the transistor M1, I replaced it by a transistor with a DC bias. يعني I removed the RD and I plugged in another transistor with a DC bias here. Okay, sorry. Okay, I plugged in a transistor with a DC bias here, and let me draw it. So I put this transistor here. وهيدا DC. So what happens to this transistor? What's the effective is a هيدي V in, and this is my V out. I can really replace it, okay, with its effective resistance, right? يعني كأن عندي هون ال RO3. Okay, هيدا half circuit. With the same here, it's as if I have on this side, really instead of all of this, RO4. يعني I'm just using transistors to create RO3 and RO4. Okay, and really, where do I get this? How do I build the bias? From a current mirror. يعني هاي بتكون جاية من current mirror. Right, and the current mirror is sending the V bias. And the same here, a current mirror may be generating this in this form for the current source below. So what is RSS here? شو ال RSS لهيدا الترانزستور إذا هو عنده DC? I'm looking down the drain. Okay.
5.
RO5, exactly. So RSS is RO5. Okay, so عندي RO5 هون لكينا، عندي RO3 اللي هي بتساوي my RD، وهير my RD is equal to RO4 and this circuit is equivalent. Okay, clear for everybody كيف ال RD هي RO4 و RO3 والcurrent mirror عندها الcurrent source عنده resistance RO5. Okay, طيب. Let's look now at a more complex circuit. So the voltage gain is simple. Just plug in RD for instead of RD, RO3, RO4. هلا طبعا نحن the equation is symmetric, so we will assume that the two transistors have the same resistance. يعني we want RO3 and RO4 to be the same لحتى يضل في symmetry بالcircuit. Okay, let's look at this complex circuit here. This complex circuit بناخده by parts. Let me color it. Okay, so let us take it by part. The first part is the current source. هيدا current source. It has an effective RS لأنه عنده bias. هدول كلهم DC. VBs are all DC. It has an RS, and the RSS is really looking into two stacked transistors, which we can approximate as GM9 times RO9. هذا RXY هو ضرب RO10 approximately if I want to remove the other terms. So this I am done with it. Now I will have, when I am studying the differential mode, يعني if I have VID over 2 here and I have minus VID over 2 on this side, this node will still be virtual ground. Okay, so my circuit will be literally, I have M1 with VID over 2 here, هيدي grounded, هيكون عندي الكاسكود, this is DC, okay, this is VO1, I know how to find the gain for this circuit, and then this upper part here, يلي جاي عليه DC bias, it's coming from a cascade current mirror. So this upper part here, really I only care to find the effective loading, its effective RD or its effective R load on my cascade amplifier, right? So the effective resistance, it's looking from the drain. Okay, with these two stacked transistors, هيدي is a virtual ground for me. It's a ground in small signal analysis. So this resistance is approximately GM5 times RO5 times RO7. And we have a formula that tells me how to get the gain for this circuit. So I can really derive what's VO1 على VID over 2 and so on and so forth. So I just break it into pieces. The same for the right side. I break it into pieces, and طبعا الكاسكود نحن we did not derive it when we have resistance at below my transistor, so it becomes a little bit involved for the common mode, but at least for the differential mode we should be able to know how to map it to the existing formulas. Okay, anybody has any question? طيب بكرة.
Yeah,
Yes.
Professor, what did you say in the resistance looking up into the M5 or M7? And shouldn't it be RXY, I guess?
Yes, it is an RXY. So the RXY is really GN times RX times RY plus RX plus RY, right? We are just, for brevity and because sometimes it is dominant, I'm just taking this term here.
All right, thanks.
Okay, يعني we definitely want to include this, but approximation, it will be this. Thank you. Okay, طيب, anybody has any other questions? Okay, great. طيب, هلا لكينا we know how to divide and conquer. So the same that applies for the MOSFET applies to the BJT. يعني for the BJT, what will happen is that the only difference is that IC1 will become IE1 and IE2, and the sum of IE2 and IE1 is equal to I. Okay, and for the differential amplifier, what is going to happen is I can have two possible implementations. One implementation where I will have the emitter node directly connected to the current source, and another implementation where I have a resistor RE between the emitter and the current source, and this is added to increase the input resistance. لأنه it has the same mirror effect مثل ما كنا نقول R pi plus beta plus 1 times RE. In a similar fashion, here this increases the input resistance, so we may have it within our implementation. Now the same concept of the half circuit applies here. يعني in differential mode, this node will be virtual ground. Okay, but first here we will derive it again using the T model, and for the T model again the transistor will have GMV pi. Okay, and in between here we have the little resistor RE, where RE is equal to R pi over beta plus 1. يعني هيدي الcollector node, this is the base, and this is the emitter node. So don't be confused between the little RE, which is part of the model, and the big RE, which is the resistance I put after the emitter, between the emitter and this node that is going to the current source. Okay, so let's see how the derivation continues and what we can use here. Great, so بلشنا with small signal for the basic one with no big RE. I replaced each transistor with its model. So this is the model for the transistor here. So I have GMV pi. Okay, I have RE. This is my first transistor. And here I have GMV pi 2. And here I have RE as well for the second transistor. And this is the common emitter node for both. And I know between this node and this node, I have VID. Now here it is simple for me to derive the current that is flowing in this branch. What is the current that is flowing in this branch in those two resistors? I have the voltage from here to here is equal to VID. وهيدا current, it's the same current that is flowing here. Okay, so let us see. So he tells me that IE1 is equal to V pi 1 over RE. But it is also equal to VID over 2RE. We can add the two resistors, and I know from here to here it is VID. So IE1 is equal to VID over 2RE, and we know that IB, by virtue of the BJT, is equal to IE over beta plus 1. Okay, so this means it's equal to 2ID, VID, pardon me, over 2 RE into beta plus 1, but RE into beta plus 1 is what? R pi. Okay, so by the fact that the same current flows in this branch, and by the fact that the voltage from here to here is VID, I am able to find IE, and then I'm dividing by beta plus 1 and I'm finding IB. Okay, this IB, أنا عندي هون VID between those two nodes. Okay, and now if I find IB, really Rn is equal to VID over IB, right? VID over IB. Okay, so what is Rn? هي VID على VID على 2R pi, and so this is going to be equal to 2R pi. Okay, فإذا the input resistance now, since VID is connected to the bases of two transistors, okay, يعني إذا بدنا نرجع نرسمه للcircuit, if we look at the two transistors and assume that this is a common ground, since it is connected between them, I will see the two R pi هدول in series لأنه هي R pi from here to here and R pi from here to here. So I'm seeing 2 R pi now by my input. Okay, so the differential input resistance is 2 R pi. This is the only thing that is different in the BJT compared to the MOSFET. Okay, okay, and if I have RE, يعني إذا رجع وعد لي السيركت وحط لي هون RE and he put here RE, then IE هتصير VID على 2 into RE plus big RE, and IB1 will be equal VID over 2 beta plus 1 times RE plus 2 times beta plus 1 times big RE. So it will be equal VID over 2 into R pi plus beta plus 1 times RE. Okay, and this will imply that the input resistance will be equal to 2 into R pi plus beta plus 1 times RE. Okay, فإذا plugging in RE is going to increase the resistance. بدل ما يكون 2R pi حيصير 2 into R pi plus beta plus 1 RE. If you recall, when we used to study the transistor with a resistor RE one-sided, كنا نقول input resistance is R pi plus beta plus 1 times RE. هلا الرول لما we're applying it differentially to two transistors of the differential amplifier, now we see twice that resistance. Okay, فإذا here he's telling me it is 2R pi, and he's saying that here it will be 2R pi plus 2 times beta plus 1 RE. Okay, great. Now the differential voltage gain. So the differential voltage gain, I can build it from the half circuit. I don't have to rederive it. This node will be grounded. I will have here VID over 2 on the right side, left side, and minus VID over 2 on the left side, هيدي RC. So the differential gain VO1 over VID over 2 هي minus GM RC parallel to RO, and I can derive it to be VC1 over VID بتطلع معنا minus half GM RC. Okay, and on the other side it will be plus لأنه I'm applying minus VID over 2. Okay, so this is the differential voltage gain, and this means that the differential output هو VC1 minus VC2 over VID اللي هي تطلع minus GM RC. Okay, differential gain, differential output. And now in the presence of RE, let me derive this equation for you quickly. In the presence of RE, what is going to happen is I have RE, and this is the common node that was connected to the other transistor. Whenever I am applying differential gain, يعني هون VID over 2, here minus VID over 2 on the other side. And on the other side, I have minus VID over 2, okay? And this is RE. In the differential mode, this node automatically becomes the virtual ground. So I will break my half circuit here. I will remove the other half circuit, okay? And now this node is really ground for me. I now know how to use, this is what I want to find the gain with respect to the output node, pardon me, with respect to the output node VC1. Okay, this is a common emitter with emitter resistance. Okay, the equation for it from the small signal analysis, pardon me, مش هاي بدنا الجين, sorry, بدنا الجين, sorry. The equation for it with the small signal analysis is this equation here. Okay, so this equation here, it says minus GM RD over 1 plus, يعني minus GM RC, هيدي عندي هون RC over 1 plus GM over alpha times RS لإلي هون هي RE. I'm going to multiply by alpha over GM. So بتصير هون minus alpha RC over alpha over GM plus RE. Now alpha هي beta على beta plus 1, right? Sorry, alpha is beta over beta plus 1. أي مظبوط. Alpha is beta over beta plus 1, and GM remains here, and then GM R pi is equal to beta, right? So شو بصير عندي هون؟ يعني R pi هي beta على GM, right? So alpha over GM is equal to this quantity. بس أنا I know إنه R pi هي beta على GM. Okay, so this would be equal to R pi over beta plus 1. Okay, so this becomes minus alpha RL over R pi over beta plus 1 RE plus big RE. Okay, so for the BJT, I can express this as minus alpha RC over RE plus the big RE that is here. هيدي بس reformulation. يعني انتوا لو اخدتوا هاي you plugged it in, حطيتوا هون RC وحطيتوا هون RE, it would have been the same. Okay, so this equation that is presented here is really what they have presented for me here. So they is telling me that if I have my circuit with RC, with RC and RE here, the equation is going to be minus alpha RC over RE plus RE for the differential gain. يعني بس he used the formula sheet and multiplied by alpha at GM up and down and found the equivalent equation. Okay, so great. We still have some time before the short quiz. Don't worry for those who joined now. But great. So now I have this formula. So I have the equivalent circuit when I have RE. And he's telling me, confirming again, that even with a non-ideal current source that has finite resistance, the common node اللي هي بين two differential branches is still going to be grounded لما نحط VID over 2 and minus VID over 2. Okay, so it's just confirming that the common node will be grounded. هلا بالنسبة للcommon mode gain, he does not derive it with REE. He starts with this circuit, okay, where I have a current mirror here, and again I have a current mirror, yeah, current source at the bottom, and I have the two circuits, and I have here VICM, and I have on this side VICM. And he says, similar to the case of the BJT of the MOSFET, I'm going to assume if this has an effective REE, that I will have 2 REE in each half circuit, and I will break it down. Okay, so similarly we're gonna split the circuit in half, but this time we will consider twice the impedance at the common node for every transistor. يعني إذا هاي هي E هيدي هي E, I will have 2 REE لأنه 2 REE in parallel بيعطوني 1 REE like we explained before. And now I can find the common mode gain. It is simple. VC1 على VICM هي minus RC minus alpha RC, right? Over REE, 2 REE plus RE. Okay, so this is the gain for this circuit, and like we just derived before, and بيطلع عنا هيك ال common mode هو 0 إذا الانputs قد بعضهم, and we will continue next time. Okay, let me flip now to the